Hey guys, we're looking at task 4.4. We're right here using the derivative, and I'm going to talk through number 4 and number 6 and then post my work afterward as well. So I want to remind you that the name of this task is using the derivative. So at every single point, we're going to have to take a derivative as either our first step or our second step somewhere down the line. So let's start with number 4. Number 4 starts by asking us find all the values for which f prime of x is undefined. So f prime of x, I want to remind you, that is our derivative. So it wants to know where this derivative is undefined. That's what it's asking. So we need to, step 1, take the derivative. So I'm going to write find the derivative f prime of x. So let's go ahead and do that. Let's find our derivative. If you hear my daughter in the background, guys, just roll with it. So I'm going to rewrite f of x using just powers. That's going to help me be able to use the power rule. So that square root turns into a 1/2 power. So 4x to the 1/2 plus x. So now let's do the power rule here. F prime of x equals coefficient times the power of 1/2, and drop the power. 1/2 minus 1 is negative 1/2, and then that just becomes 1. So here we have 4 times 1/2 leaves me with just 2, and we move that square root into the denominator. So that right there is our derivative. So there we go. Step 1, we need to actually take or find our derivative. Okay, so now let's go back to the question. It says, where is it undefined? So step 2, find undefined points. And here I'm going to specify undefined x values of f prime of x. So I'm going to write f prime of x. Well, actually, we already wrote it right here. It's 2 over the square root of x plus 1. But let's just talk through what would cause a function to be undefined. The first thing that we're kind of familiar with at this point, what would cause a function to be undefined is dividing by 0. We cannot divide by 0. So let's look back at our function over here. And let's ask the question, well, what x value would cause me to divide by 0? Meaning, what am I actually plugging in here that would make me divide by 0? That's just 0. That's just 0. So if I were to plug in x equals 0, I would be dividing by 0, and I would be undefined. So, second thing, what also would cause us to be undefined? What would cause this function to not actually function? Well, if we look at it, we've already taken care of the dividing by 0. The other thing we have to pay attention to is this square root. That square root, well, what can we not take the square root of? We can't take the square root of negative numbers. We cannot take the square root of negative numbers. So looking at that function, we can't plug in any negative numbers. So let's set a domain for that. Negative numbers would be negative infinity all the way up to 0. All the way up to 0. That includes every negative number. So let's put these two things together. What would cause this function over here to be undefined? Well, dividing by 0, meaning actually plugging in 0, and throwing a negative number under that square root. All of that would cause our function to be undefined. So when we put that together, that's all the numbers negative infinity up to 0, including 0. So that right there is our answer. That is what causes our function to be, causes our derivative, to be undefined. Okay, let's take a look at number 6 now. So number 6 is really similar to number 5. So if you did number 5, this one is really, really similar. It's going to start us on the same premise that we are writing the equation of a tangent line. Equation of a tangent line. So let's write our goal out first. Our goal is to write the equation of a tangent line. And I always like to remind myself of the form. Y equals m, that's the slope, x minus x1 plus y1. Remember, m is our slope, and x1 comma y1 is any point on the line. In this case, it'll be a point that's both on the line and in this function they've given us. So our goal here is to write an equation of a tangent curve, which means we're going to need the slope and we're going to need some point x comma y. So what do we know? Well, first of all, let's write that out. We're going to need our slope and we're going to need a point. Let's read the rest of the question to see what they've given us. They have told us that this equation needs to be parallel to the line y equals 5x minus 3. Again, parallel to y equals 5x minus 3 means they need to have the same slope. Means same slope. So that means for our slope, we're looking at this number right here. Well, there we go. We have a piece of the puzzle. The piece of the puzzle is that the slope equals 5. That is one thing we're going to put into our equation. Cool. So we have half of what we need. I said we needed slope. And now we know that that is 5. We also need a point on the line. And this is where it gets a little bit tricky. We know what the slope is, but we don't know where the slope is 5. So the next question we're kind of asking ourselves is, where is the slope 5? And this is where, if we had done this seamlessly after module 3, we would have kind of been in this mindset already. Back in module 3, what we were doing is we would find a derivative. Remember, derivative means slope. We would find a derivative, and then with that derivative, find the slope at a certain point. So let's start by finding the derivative. I told you that that's going to happen at some point in all of these problems. Let's do that now. So if our function is f of x equals 2x squared plus x minus 3, finding the derivative with the power rule, f prime of x equals 4x plus 1. That is the slope everywhere. That is the slope across the whole function. But I want to know where the slope, or where this function equals 5. So let's do that. Let's actually solve this for 5. So there we go. At 1, or at x equals 1, our slope is 5. But remember, our point needs to be in the form of x1 comma y1. So I need to find that y value. Meaning I know now this function has a slope at x equals 1 of 5. Can I find the y value attached to it? Well, I can. Let's plug it in. F of 1 is 2 times 1 squared plus 1 minus 3, or 2 plus 1 minus 3, or 0. So there we go. We have our x comma y now. This is 1 comma 0. That is our point. So let's step back for a sec. We know that we're looking for the equation of a tangent line. And we have that equation right here. All we needed for that equation was a slope. Well, there it is. And a point. Well, there it is. So let's put these two together. y equals our slope of 5, x minus x1 plus y1. So as we simplify that, we could leave it just like this. Y equals 5 parentheses x minus 1. Or if you want it traditionally in like a slope-intercept form, you could also write it as y equals 5x minus 5. And nice little double check for you is originally our only stipulation for that equation of the tangent line was that it was parallel to y equals 5x minus 3. Well, that line has a slope of 5. Our line has a slope of 5. That's just a nice quick check to make sure that you have done what it asked for. Okay, hopefully this helped out for those of you who weren't able to make it to office hours today. Feel free to post some more questions and I'll do my best to post a picture of my work and some short videos to go along with it.